is one of my favorite proofs involving the equidistance theorem. You can see here that I'm told that AB is congruent to BC. I'm told that AE is congruent to EC. And I'm supposed to prove that AD is congruent to DC. Now you look at this and you say, well, you're not proving a perpendicular bisector. Why do you think this is an example of the equidistance theorem in the first place? Well, it's actually pretty simple. Anytime you see a segment that looks like it has a perpendicular bisector, especially if you see some other congruent segments around that, you may have a case where the equidistance theorem can be used. And in particular, if you can use it, a lot of times you're going to save a detour proof. So if you notice here, it looks like segment AC right here might have a perpendicular bisector. And if I can show that, I can use that fact and I can get some really helpful information. So if you remember how I do this, I always highlight the segment that's being bisected. Remember, to show that you have a perpendicular bisector, you have to show that you have 2 points that are equidistant from the endpoints of that segment. Well, if you notice, B is shown to be equidistant from the endpoints of that segment. F looks like it could be. We're not told that information, though. However, E also looks like it could be, and we're told that. There are my 2 points. So step 2, I know that segment BD is a perpendicular bisector of segment AC because I've already got those 2 points. Now again, you look at that and you say, well, why do I care? Why do I want a perpendicular bisector? Hang with me and you'll see. So that's, you have 2 points are each equidistant from the endpoints of a segment. Then they determine the perpendicular bisector of that segment. Here's why that's so incredibly important. Remember what I'm trying to show. I'm trying to show that AD is congruent to DC. Well, remember that any point that lies on the perpendicular bisector of a segment is equidistant from the endpoints of that segment that gets bisected. So once I've shown the perpendicular bisector, I know that B is equidistant from the endpoints of AC. Of course, I knew that already. But I know that any point along this line is as well. So F is, again, that doesn't really tell me anything that I need right now. It tells me that E is. I already knew that. And finally, tells me that point D is equidistant from the endpoints of segment AC, which is the same thing as saying that AD is congruent to DC. Why? Because it lies on the perpendicular bisector. So if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. And at that point, I'm done.